Alrighty, here's the second practice problem. That first word's actually a typo. It should be acrylonitrile, which is a starting material for the production of a kind of synthetic fiber acrylics. If you've ever heard of ABS plastic, that's what it's used to make. And it's made from propylene, which is C3H6, by reaction with nitric oxide, which is NO, according to the following reaction. There's the reaction. It's already balanced for us. So what mass of acrylonitrile can be made from 21.6 grams of C3H6 from the propylene and 21.6 grams of nitric oxide? So those are our two givens that we're looking for. And the product that we're going to be converting both of those into, and so remember we go from grams to moles, just to begin with, and the product of the moles that we're going to be going to is going to be the C3H3N, which is the acrylonitrile. Alright, so step number one then is to calculate out the stoichiometry, do the stoichiometry for our two givens. So let's start with the 21.6 grams of C3H6, the propylene. And the molar mass of propylene is 42.0 grams C3H6 for every 1 mole of C3H6. Grams cancels out grams. We're going to go one more step, so we're going to go from moles of propylene to moles of acrylonitrile. And if we look up at our balanced equation, so there is 4 moles of C3H6 for every 4 moles of C3H3N. So it's a 4-to-4 ratio. Cancel, cancel. And we can solve this out to see how many moles that would produce. And if we were to react to the propylene, 21.6 grams of it, we would get 0.514 moles of acrylonitrile. Alright, the next step, we've got the same number of grams, but this time it's nitric acid, so we have 21.6 grams of nitric oxide. 1 mole of NO weighs 30 grams. And if we look up at our balanced equation, this time we have 6 moles of nitric oxide, along with the 4 moles of acrylonitrile. Cancel, cancel. So what this means is this guy can produce 0.480 moles of C3H3N. Okay. So who would our limiting reactant be? Let's say it together. Our limiting reactant is nitric oxide. So we cannot produce 0.514 moles. We won't have enough. We're going to only make 0.480 moles of acrylonitrile. So that means our C3H6 is going to be in excess, and our nitric oxide is going to be our limiting reagent. It's the one that we're going to run out of first. Alright, so last step, we're going to take that limiting reagent number and we're going to go that final step from moles to grams. So we said that we're going to produce 0.480 moles of C3H3N, and C3H3N weighs 53.0 grams. C3H3N for every 1 mole of C3H3N. What this means is that we will produce 25.4 grams of C3H3N. So that would be the maximum amount, our theoretical yield, of acrylonitrile. This question doesn't really ask us to calculate the excess. You can do it if you want some practice. I'll go ahead and do it on here. If you want to give it a shot by yourself, pause the video real quick, then check back in to see what's going to happen. Okay, so let's go ahead and calculate how many grams of excess we have left over. So we already said that nitric oxide, that's going to be our limiting reagent. That's the one who decided how many moles we could make. And C3H6, the propylene, that was the guy who is in excess. So if we decided that we can only make 0.480 moles of the acrylonitrile, we want to convert that into grams of C3H6, our excess reagent. So there is 4 moles of C3H3N, getting that from the equation, for every 4 moles of propylene. And 1 mole of propylene still weighs the same amount that it did before, and that's 42.0 grams. Alright, so if we do this, it's going to tell us how many grams of propylene we actually needed to complete this reaction, and the number we get is 20.2 grams of C3H6. Alright, so if we started the reaction with 21.6 grams of C3H6 and we used up 20.2 grams to complete this reaction, that means in the end we will have left over 1.4 grams of excess C3H6.